Hi, my name is Alexis Vera, and this is my oral presentation for my PowerPoint for my Physics 2 project. So the topic of my project is four-eyed physics. So basically glasses, the whole four eyes type thing. So I'm focusing on this as my topic because I've always wondered why everybody in my family has needed glasses but me. So I was kind of curious to see what causes people to have bad vision, or why do they have bad vision. And also again, I always look at I'll grab my parents' glasses for them or my brother's, and they always look different. The shape of the glass itself or the shape of the lens itself is different. So I was wondering, well, that's probably has something to do with physics, which is we've talked about today or during this class, during this semester. So I thought it'd be cool to kind of focus in on the physics behind the glasses that my family has and everyone else now. So first thing we're going to talk about is how does the eye even work? So the eye collects visual information by focusing in on the amount of light through a lens. So naturally, we have lenses in our eye naturally, but those aren't always the best. So that's why you have people who have blurry vision, whether it be blurry things from afar, blurry things from up close. So that's how the eye works naturally. So the process of that is first, your cornea is going to contract or relax depending on if things are further away, up close. Your cornea is responsible for about 2/3 of that focusing ability. The other part of it would basically be the muscles in your eye contracting and all that stuff. So that's where your other 1/3 comes from. Once your eye is focusing in on something, whether it be from afar or from up close, it's gonna that light that hits that goes through your eye is now gonna hit a lens. That lens then directs that light towards your retina, which is located in the very, very back of your eye. Depending on how the light, which passes through the lens, then hits your retina, is how you're gonna actually end up seeing an image completely. Some people, depending on their angle of their lens, they can be farsighted or nearsighted. Um, so what determines farsighted or nearsightedness is the focal length that a person actually has. The focal length is the distance between the cornea and the retina, so the amount of space that allows the light to go one way or the other directed. So when it first enters you could have a far focal point, you can have a near focal point. Again, the farsightedness, nearsightedness. So if you have a far focal point, you're going to be farsighted. Kind of makes sense, right? Yeah. If you have a near focal point, then you're going to be nearsighted. So you can just see in the image here how that person's lens allows them the angle to be a further angle as opposed to the person who has a nearsighted vision. Their angle of the lens is going to point closer so they can see things at a closer distance. So the lenses of glasses change this focal point of a person to allow them to see things further or closer. So depending on an individual's natural focal point, their eyes may be farsighted or nearsighted, which is just what that slide was showing. Vision type. So again, nearsighted is to have blurry vision at a distance. So you can see things up close perfectly fine. You can read a book perfectly fine. But if you're asked to go see something from afar or you're looking at something far away, it's going to be really blurry to you. So to fix that, what a doctor would prescribe you is a diverging, or another word for that is concave lens. So we talked about this in class. So just like we've talked about the other kind, farsighted people, which is essentially to have a blurry vision for close. You can see things far away, everything's fine, but if you're going and you're going to read a text on your phone, you're going to be squinting like this, even though it's closer, because your focal point is further away. So to fix this issue, you would have a converging or a convex lens, excuse me. What those look like are, so your converging lens for that is for your farsighted people. It's going to have that outward shape, almost kind of looking like an almond there. And it allows that focal point, as you can see from the arrows, to be right there at a closer distance. As you can see for your diverging, which would be for people who are nearsighted, the arrows are pointing outward, so it allows the person to see things outward, so further away. So that's the kind of lens you would have on the glasses for a person who's nearsighted. And you can see the angles on those, how they change. This these angles then come back to the eye, which allows your retina to get that light exactly straight on to actually see an image more clearly. So that is actually my presentation. It was pretty simple actually. It was really I didn't realize that glasses actually had different converging, all that concave, all this stuff, depending on whether a person was farsighted or nearsighted. I always thought it was just one type of like prescription. There wasn't different types of lenses, but coming into physics, I now see that it's not, that there are actually different angles that go into it. And I always thought the number prescription of your glasses was like the thickness of the lens and everything like that. But it's actually the angle of which all that is. There's more into it than just like the thickness of the glasses. It's actually the angle of which the lens itself is made. So I thought that was pretty cool. And now I kind of know how me and my family are kind of different. And I think that's cool. So yeah, I hope you enjoyed my presentation and learned something. And thank you so much.